Shika. No. JavaScript. Hey guys, thank you for coming in. We want to start the mob. Oh, ni Kevin ameandika kwa calendar. Anyway, we want to start the mob. I'll be leading you through today just so we go faster. Crafty says there are technical difficulties. I haven't shared my screen. Wololo. Let me share my screen. Yeah. People don't want to join the mob today. So sad. No, join right now. It's already 3. Isha for 10. Sigu Mise join. Crafty won't be joining us because he's busy. Okay, we were on, I guess. Where were we, Kevin? String methods. Yeah. We finished the substr and the substring. We finished. Awesome. Oh.
Strings. Yeah, there.
Yeah. Extracting string characters. Mise nitakupiga. Imagine, Nasigu. Unajua I'm the lead of mobs and meetups. Sigu, you're joining? Why not? You should. Mtu hata kuwa na join kutakuwa na fine, by the way.
Mmejoin kapo di wawili. Nilikupo di wawili.
Okay, so the char at method. Okay, let's start from this description here. There are 2 safe methods for extracting string characters. The first one is character at position and character code at position. So we're going to look at extracting string characters. So like this is almost similar to the slice and the substring method that we did earlier. So let's look at the char at method. I don't know how to pronounce this. So the char at method returns the character at the specified index position in a string. So it takes one parameter, which is the position of the index, and then it returns that particular index that you've told it to return, the value of that index. So for example, we have a variable here called string. It has the string hello world. And then we want to return the character at index 0. We'll do string.char at 0. This will return the value of index 0, which is h. Any questions about char at? None. Okay.
Some other example problem.
Oh,
As in,
try.
yeah.
Okay. Let's do it on our console. Yeah. Okay, so we have a string. Hello world. There. So we want to extract the first character, which is at index 0. So we'll do str dot zero. So this should bring us h because h is at the 0th index there. And then we could try with 5. It brings the empty, what is it, the white space, because it's at value number 5, index number 5. Okay. Awesome. I'm trying to move this thing, it's not moving. -1. Sorry, I do not know what has happened. You may hang. I am hang. Yes. Why is things hanging on my computer today and they haven't ever hung? Yeah, you're close to me. You're not reversing me. Um, I'm trying to close all these things that I have opened. Hmm? Do I wanna do what? Okay. Processes. Hide. On what? Memory. Oh, memory. Mm-hmm. Oh, tabs. Sorry, where have I gone? Okay. See, it has stopped broadcast. Two of them are being used. Only one is not, and I'm not sure it's which one. I only see two. I closed this one. This is where I'm using the W3 schools. Mm-hmm. Like to the this one. Okay. I'm here. This one. Or I open another one. Just two. Actually one. This other one nihi. Nifungue window ingine. Tuko wapi? String methods. Nimepata. Replacing. Oh, there. Okay, so we had looked at char at. So now we're going to look at character code at method. Or negative one. Let me drag this thing down. Is our string still here? Nah. Str. It was hello world. Terminate what, Kevin? Inachekingi. Ama mtu mwingine aendelee, kompi yangu ikirestingi.
So you need to open this. Okay, hello. Unanisikia? Okay, sorry guys. The effect of those who don't have RAM trying to use Chrome. So let's just move on. Unless you have 6 GB RAM. That's the only point you're allowed to try use search. Okay, so we were to try out -1 as a position and see if it works. What the fuck is happening here? Hide, then we do that. So str my name. That's my name. Okay. Str. So whenever you ask for str, it will give you my name. If you do str dot at -1, let's see what happens. Brings back an empty one. Yeah, 1 happens. But there's nothing like -1. -2, nothing. -20, still nothing. Okay, so you can't use negative to do that. Okay, let's see. Character art, then we have character codes. This is probably the ASCII codes. This might be the ASCII codes. Let's look up the ASCII codes here. Here you are. Show more. Okay, for the ASCII codes, we have the decimal, the hexa. It's called the hexadecimal representation, the octal, the HTML representation, and the definition of the character itself. Okay, so for space characters, they have 32 as their decimal. Okay, their hex is 20. If you look up uppercase A, it's 65 as a decimal, then 45 as a hex. In HTML, you can do this. It will be A. If you want to write art in HTML, you can also do that. It should work. Now, I think these are the character codes we're talking about right here. The decimal representation of the characters of the keyboard. So this describes all the characters, hopefully all the characters on a standard keyboard. Okay, whether lowercase or uppercase. The caps lock group, hello. So whenever you caps lock and press A, it will send 65. Where is that? 65. That's what it will send. If you uncaps lock and type A, it sends 97 as the character code. So these are character codes for all the characters on your computer. This is tilde. Tilde is 126. Interesting. Any character that we think is not here, less than, greater than, oh geez, they're here. So all your characters are represented in the ASCII codes. Okay, so if you want the character code at that particular place, okay, at that particular position, sorry, then you ask for its character code and give it the position. It will bring you back the character code. Now we can try out that name equal tilde exclamation hash ninja. So that's our name. If we do name dot character code at position 0, position 0 is a tilde. We earlier saw that tilde will be character code, I think 126 if I'm not wrong. Yep, 126. So let's try and see what happens. Yeah, brings back 126. Okay, so these are the ASCII code representation of the same. Okay, oh, I didn't have the caps lock group. So if we do for position 5, I'm not sure which one it is, 1 or 5. 0, 1, 2, 3, 4, 5. That's I. How about space? The white space. 0, 1, 2, 3. That's 3. White space should be the null, acknowledgement, the tabs. White space. This is escape. Oh, this is the space. 32. So we expect 32 at what position? 0, 1, 2, 3. Position 3. We're done. Okay. So how can you access a string as an array? Accessing a string as an array is unsafe. So if you try treating a string like an array of characters, it's not advised, okay? Because as per what they're saying, it's very unsafe and predictable. First of all, okay, I don't really care about this these Internet Explorers, but it won't work for them. It makes string look like arrays while they're not, okay? So this is the nice fact about this. If you do, let me just copy this. Sorry, copy this, have it here. And if you do str at position 0, what's the output? It will be 8. Position -1. So is it that if you have an array of what's happening? So you can't even access arrays using negative positions. Or what am I saying? Okay, let me try this out. 1, 2. And it's r dot, no, not dot. 0 will be 1, okay? And at -1, undefined. This is weird. Let me remove these timestamps. Makes it look cluttered. Okay. So this won't work for the array, and it's not working for the string also. Now, if we have an array AR with the value 1, 21, 5, if we do AR at position is 0, 1, 2, if we do at position 3, then we give it a value of 34. What happens to AR? will the value be added to the array? If we say that at position 3, your value is 34,
Yeah, it should.
it should. Getty was of the other opinion. Why? You don't really have to explain if. We're trying to, because we're telling it at position 3, give it a value of 34. Kevin, why do you think it will work? Or it will just work?
It's like we are reassigning the value of
You're assigning the value at that position. Okay. Oh, umelock screen kwangu. So you also need to lock at your. Yeah. Okay. So let's look up that value. 34 will be in there. So it assigns position 3 to that. What if we assign, out of curiosity, what if we assign position 6? Yes. Why not null, 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 null? I'm thinking it will be null or undefined, undefined, undefined. But most probably it will be a null. It can't use a 0, yes, because it might have been a string. It might have been an integer or a number, I mean. It might have been a string, a number, or a boolean. So it can't use 0. Oh yeah. Make a guess.
I said a null or undefined.
But in my opinion,
No.
it will be either. Or does it assume the 6 you've given it and appends it immediately after the last?
I don't think it can assume because we are telling it at index 6.
At that
No,
position.
yeah, or at that position 6. So it can't just put it immediately. That is not position 6. That
Get any idea? Empty, null or empty. So it will be, so in your opinion, it will look like this, then empty, then 34. Oh, empty, like that. No, we don't have. Nil might be null. Yeah. Okay, let's check out the value. No. I think these are Firefox representation of the same.
There was this time I was reading about arrays, and there was something about the arrays having a hole. If you remove,
Elements.
yeah, without pushing or popping, without popping, yeah, popping pops the last one. Yeah, so if you remove the middle elements, your array will have holes.
So right now we have position 0, 1, 2, 3, and 6. So Firefox is talking about empty slots. We can try these out on, 2 empty slots. We can try these out on Chrome equivalent. Correct. Then we do at position 5, give it a value of 90. Empty times 2. So it's literally empty. Nothing like undefined. Okay, so we can, yeah, it's a data type, but it actually means nothing. Uh-huh. No, we can't use a 0 because probably we're sure it was yeah. If it can be any data type, that it can be null. Yeah. Why do we normally use null? Any data type that is not there, we represent it by null. Whether it was an array without a value, that's null. An object that you want to invalidate, you set it to null. An integer, a variable that's supposed to hold an integer but still doesn't hold the integer, you can say it's null or undefined, whichever. Okay. So another interesting thing, what if we ask for the value at position 4? Undefined.
It's undefined.
Undefined is an object. Undefined is of type object. But is it null that is undefined? Oh, it's null that's an object. Undefined is still undefined. Okay. So we move on. Oh, the reason as to why we could not do this was if we have the string str, let me just do that. Has hello world. So if we try, say, 0, 1, 2, 3, 4, then at the 5th position, we give it E. What happens? The 5th position is at the space. Yeah. Okay. Instead of B, let's do that. Dash. Hello dash world. Kitty. Hello dash space world. Kevin.
Hello, dash world.
Hello dash world. Okay. If my memory serves me right, then you can't treat strings as arrays. So you can't set values in strings by assigning them. So if you do that, you'll bring back the dash, but str will not have the dash because it is not an array. It is a string. No, it's not about immutability. You just can't access positions and assign them values in strings. You're trying to treat it like an array while it's not. Okay? So you can't assign. That's the second point. That won't give you an error, but it does not work. If you want to read a string as an array, convert it to an array first. Parentheses?
Like when you want to refer to an index.
Parentheses are method calls. Whenever you have these parentheses, you're calling a method. A function call, wherever you use them. This is access. This is calling the method string and passing the argument 5. String is not a function. Okay. So if you want to do that, convert it to an array first. How do you convert it to an array? You can split. So if you tell it to split on corner, then you give it a comma, it will split on common, give you back an array. Can use that. Then we can now split the text using commas. 0, 1, 2, 3, 4. So 0, 1, 2. We can set txt at position 2. At that position, give it a value q. Now this is an array. What happens? Get it? Kevin?
Oh, I think we are still working with the initial string.
Yeah.
So this will still not work.
No, this is,
We are,
we've split it. We assuming that we split it.
so in short,
Yes.
of txt.
Oh yeah. So I need to do this. Then we give it position 2, we give it q.
Oh, now we have abqd.
ABQDE. So Lucy was for ABQDE. Getty was for ABQCDE. And Kevin, same as Lucy. So we're telling it that at position 2 we have q. So it replaces whatever is at that position. It doesn't push it. You've not told it explicitly to push it forward or backward. You've just told it to give it that particular value at that position. So it should be ABQDE. Then probably you can join, maybe. Call the method join. That's a method call. Okay. So yeah. Which one? This is still, yeah, it's still an array. This is a string. Yeah. Join in most cases brings back a string. Okay. So we can do the split. How do you split hello into characters? You just call split. Then you don't, you pass in, is this, no, this is not an empty string. It is an empty string. If it has a space, what is it? So if that's our value, then we pass in that, then we put in a white space there. That won't work. Yeah. So okay. So how do you call this? Is it an empty string or? uh, okay. Oh, okay. We can do. So I'm trying this out. Character code at 0 with the white space. I expect probably 32, and that's 32. Without that, not a number. Okay. But for empty strings, it will be not a number. Yeah. It's an empty string. It has a character because you can even represent that character here. This is the character table. That's key code for all the characters on the. A character is anything you can type in using your keyboard. No, a character is anything you can type in using your keyboard. Yeah. Yeah. Mm-hmm. If we had hello space world, the usual hello space world. Okay, let's see, like this. Then we split this. Using what do you use? Space. It will be two things: hello and world. Without a space, let's take a guess. H-E? H-E-L-O or L-L-O, then a space, then world. So the space will have its own representation here. While you convert this to a list, if you try to split this with Are you unmuted?
I was trying to split this hello world string using a space, and every time I got the two words separate. But I wanted HELLO.
The individual character.
Yeah. So every time I used to convert it to list direct, to a list, to an array direct, rather than using split.
That's in Python.
Yes.
Okay.
But I think if I tried splitting without the space, I think it will work. I'm not sure. I'll try it.
Yeah, you can try that out. Split string. What? This is Python 2. So I need to type in Python 3.
Yeah.
Well, the first result be tutorial's point.
Maybe you should see this.
Python. Oops. Thank you. Okay, so you have string, ASCII letters, digits. I've never understood how this documentation works. Sincerely, I've never understood. Okay, that point I give up. So you, those are the ways you can use to split characters, a string into individual characters, and store that into an array. You can move over to the next section, which is numbers in JS. So in JS, a number is just a minute. Okay, in real world, a number is anything between 0 and 9. Okay, whichever the combination. Special characters allowed in numbers is the dot, EE, and what else? Just a few characters. Otherwise, it's made up of anything between 0 and 9. Okay. In JS, a number can have decimals, or they cannot have decimals. Like pi 3.14, it's usually 3.141.
What's the
What's
value
the
of
value
pi?
of pi?
3.14.
It
It
should
should
be.
be.
Don't Google. Don't Google. Don't Google. It's 3.1416. 3.141642. Huh? 814. No, there's no 8. There's no 8. 22 divide by 7. 22 divide by 7. No, this is not the value. I refuse. I refuse. I am stubborn. Oh, me say you did your thing. My battery is now running out. You know how to do your thing. So it's 1459. What did I write? Oh shit, I wrote 6. So it should be 14159. Okay. So you can represent this in JS as a number. The next thing is if you have an extra large number, you can use E. I mean the number of zeros after whatever you have. Okay. So you can have 1, 2, 3, E5. That means you have 5 zeros here. 5 zeros after 1, 2, 3. Negative 5 means 5 zeros. No, 5 decimal points after the last character, if I'm not wrong. After this last character, you should have 5 decimal points backwards. So there's 1, 2, 3, 4, 5. Yo.
If this is scientific notation, the using exponents, what about when we have 1.23 times 10 to the power? This would be 7.
Yeah, that's
Yeah,
the
that's
Yeah,
the
that is
that's the
That's the
representation
representation
of that, whatever is here. It's the scientific. They normally call it the scientific exponential notation, and it's actually a mathematical thing. I think I came across it in the one of the many YouTube channels I normally look at. Yeah, it's this is the same thing. 1, 2, 3 times 10. You have the real and the no. In this case, we don't have the real and the imaginary. That's for complex numbers. I can't even remember it. Mathematical. The mantissa, the exponent. Okay. So usually the mantissa is considered to have a binary point. Where the fuck am I? I'm sincerely at the wrong place. Okay. The floating point numbers. I just can't find anything here. Yeah, I remember the mantissa thing. Okay, yeah, that's usually there. So if you try doing this, yes, it it should be bright enough to convert this. So this should be that times 10 to the power 7. Yeah, you'll get the same thing. Yeah, it's the same exact thing. This times 10 to power, because I've just tried to do times 10 to raised to power something. In JS, I don't think you can do that easily. Raising something to the power of another. No. Okay, so we move on. JS are always 64-bit floating point. Always 64-bit floating point. Okay, so unlike other languages, it does not define different types of numbers like integers, short, blah, blah, blah. This is whatever it usually results into. So if you have a 1, internally it's represented as a 64-bit floating point number. Okay, so JS numbers are always stored in double precision floating point numbers following this standard. The format stores numbers in 64 bits, where the number, which is the fraction, is stored in bits 0 to 51, and the exponent in bits this and that, the sign in bit 63. So so we have the representation of this, the representation. We have a 64-bit memory location. So if you want to represent a number, we told that JS will store in a double precision, will store as a double precision floating point number. This format stores numbers in 64 bits, where the number is stored in bits 0 to 51. So all the way to 51. Right here, you'll have the number. Okay? Kwenda huko na kuchora kwangu. Okay? Then the exponent will take 52 to 62. So does this mean that we have a maximum exponent that we can do? The maximum exponent, because the exponent is from 52 to 62. So it can only be 10 bits, while this can be 52 bits. Then from 62 to 64, you have now the sign. It can either be a negative or a positive. Okay. So the sign is in bit 63. This is 63. So this is 63. Okay, so from 0 to 51, the mantissa and the exponent. So the exponent is 11 bits, this is 52 bits, and this is a 1 bit. Okay, so let's talk about the precision. Integer without the exponent are accurate up to 15 digits. So you're only guaranteed accuracy up to 15 digits for integers without decimal points. Up to 15. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 14. Brings back that. Then we check the 14 and add the 15. Brings that back. The 15, add the 16th. Now shit starts happening. Okay, so the maximum number of decimals is 17, but floating point arithmetic is not always 100% accurate. That's why we had this as a value of pi. Okay, So it's only accurate up to 17. But this, so if we have this is weird. Where will JS do this? Where is this 4 coming from? So you have 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now the 17th one is a bit fucked up or messed up. From where? It's only 0.2 and 0.4. Ah. Ah. So do you mean that if I have 0.1 or 0.2? So you have a 4. Oh, poleni. So to solve this problem, it helps to multiply and then divide. What the? So you have to multiply this by 10, multiply this by 10, then divide by 10. Okay, let's try this out. Now we're good. Okay, so we actually multiplying to avoid floating point numbers. Now what happens if we do the last accuracy was 17, so let's do 18. Eighteen works. Let's do 19 because we have our decimal point here. Let's do 19. Still not fucked up. I need to fuck something up. Yeah. Not yet fucked up. No, yeah, I have a 2. So let's do 20. Why is it still working? 22. We headed there. No, everything is okay. So if we do 33, then things get messed up. That's a 2. Out of nowhere. Okay, so JS uses this operator in both addition and concatenation for strings. You remember this behavior from our previous discussions. So if you have 10 and 20, that will be 30. If you have a string, then it will be 10, 20. All inputs from a form will be a string. So every time you want to add something in a form on the browser, you have to convert that into an integer first. Okay, we all remember this behavior, hopefully, all the way up to concatenation. Division was, if you divided these two, it will give you the right answer because they are both coerced. If you subtract the two, they will both be coerced, but trying to add them will land into problems. Okay. Not a number is actually a number. Okay. On top of the 0 to 9, we also have a number called not a number. So it's a JavaScript result word for indicating that the number is not a legal number. Trying to do arithmetic with an arithmetic string will result not a number. So if you try to divide 100 by Apple, it will be not a number. However, the string contains the result will be a number. Yeah, we know this. About that. Okay, how about that? They just put 1 there. Two. 1200. Not a number. Okay. Okay. We can use is a number to find out if a number is a number. Or a value is a number. So you can say is not a number. 0. This should return true. No? Yes. Oh yeah, so it should be false. Okay. Watch out for not a number. You can use not a number in mathematical operation. The result will always be not a number. So whatever you do with not a number, it will always be not a number. Whether you add not a number to, let's do 2 plus not a number. Why not 2? When you multiply 2 times not a number, not a number. Okay. Because not a number is a number. Yeah. Or the result might be a concatenation. Oh, if it's a string. No, this is messed up. Oh yeah. 5 not a number. Okay. Not a number is a number. Type of not a number returns a number. Okay, we go to infinity or the negative infinity. What's the difference between infinity and negative infinity?
The infinity of the negative phase. The smallest number they can
The smallest number they can ever be. So the smallest number is anything above, let's say, negative 1 billion. Or is it anything negative 0.0000? Actually, what's the smallest negative number? Is it 0.00 something or is it negative 1 billion? It's smaller than 0.0000.
because negative smaller than
Yes.
You are saying 0.1 billion.
0.00000000.
Still
So is it tending towards infinity?
negative 1 and 20.
negative.
Negative 1 and negative 20. Negative 1 and negative 20.
Negative
1 and negative 20. Yeah, the same thing. Negative 1 billion far away from
negative never said. Negative 1 billion.
Where? Negative is always on the left.
Negative 1 and is bigger than
Madam wife. Madam. America earphones. What's bigger between unasikia? What's bigger between -1 billion and 0.000000001? So -1 billion ni ndogo. Si account yangu atisome hivyo. Okay, so we can have infinity or negative infinity. It's the value JS will return if you calculate a number outside the largest possible number. Okay. So what happens here? We can try this out. So we can say that we start with 2. But 20 mefika. 6 minutes. Tulikuwa tuna double every time. So inamaanisha inafaa kuwa 20. 8, sinda? 16. Tulisema for every time yenye tumeextend tuna double. No? Well. So while my number is still not infinity, okay, so we have the while loop there. We execute that. That was fast. We can console log. How did he do that fast? How? How? Okay, what's happening? My number is 2. If my number is not infinity, then multiply my number by my number. Why is it not working? Try it yourself. No, I expect you to print every time. Oh, yeah, I think I get it. It won't get, no, it will, no. What's happening here? Here it is. So infinity is returned if you calculate a number outside the largest possible. So it will start with 4, 16 that. So how comes our console log is not working? No, it's not as big as you think, because this is just 1, 2, 3, 4, a few steps. While my number is not that, multiply, then console log. Let me see how it's done here. While my number is not that, my number times my number, then text equals text plus my number, then you add a break. Okay, this is a bit messed up. I don't understand why this is not working. Anyone with any idea? Oh, yeah. So we have to redefine it. Thank you. Let's redefine it, then run this again. Yep. The problem of global variables. So this is okay now. What's happening here? No idea. Debugger eval code. No idea what's happening. Okay. It's infinity, just like a number. Not a number is a number, and its value is not a number. So infinity is a number. Type of infinity returns a number. Infinity depends. It can be 1, depending on a precision. 1 can be so big that you consider it infinity. If you're dealing with precisions of, let's say, 0. Let's say you're dealing with -10 to -1000. To you, 1 might be an infinity. So infinity is relative. Yeah. Okay, if you divide anything by 0, it brings back infinity. Interesting. How about 0 divided by 2? If you divide 0 2 times, you get 0. If you divide nothing 2 times, what do you get? Nothing, exactly. Okay, so we should... I think we can stop there. Yeah. JS chooses to handle it by giving you back infinity. It's still okay, because why are we getting errors?
So if we did the square root of 1,
Mhm.
-1.
I don't know. I don't know how good it handles. Actually, you can't do that unless you define a function that gets deals with imaginary numbers. And the square root of -1 should be j. Cindy? Yeah, it's an imaginary number, j. Okay, so guys, we can continue from here next time. We have hexadecimal. After hexadecimal, numbers can be objects to... Oh, we're almost done actually. So we'll finish this up next time. Then we talk about number methods. Okay, bye bye guys.